Hi everyone, I'm going to talk about 3D printing and additive manufacturing today. 3D printing technology in the form of rapid prototyping has been around since the 1980s. It was not until the early 2010 that the printer became widely available commercially due to the fact that multiple patents with associated technologies have expired that contributed to the growth of this technology. 3D printing or additive manufacturing is a process of making a three-dimensional solid object from a digital model. Let's quickly look at the brief history of this technology. The first working 3D printer was created in 1984 by Chuck Hull. Back in the mid 80s, Chuck Hull was getting annoyed by the amount of time it took for him to make prototypes for his design. The workflow he had to adopt was to send the designs to a tool maker who would make the design in a material of your choice, but seldom would he get it right the first time. Since he was working with resins, he decided to develop a printer that would fire a beam of ultraviolet light into a bath of ultraviolet curable resin, and he was able to create his first 3D printed model. 3D printing is considered distinct as it uses computer aided design CAD files as a blueprint to build physical objects by repeatedly applying thin layers of materials in a build-up called additive process. Contrast this to traditional manufacturing process where material is often removed from a larger form in a subtractive process by cutting, milling, grinding, or drilling. Since there are no wasted shavings or other excess materials, the additive process substantially lowers the cost of raw materials used. Let's look at the steps involved in rapid prototyping. The rapid prototyping involves creation of a 3D design in a CAD software. The 3D CAD model is then translated into an STL format. There can be a number of other potential formats depending upon the specific 3D printer requirements and the 3D software that is being used. The object described in the specific format, like in the, for example, STL stereo standard template language file, is sliced along a single direction, like a Z or a printing direction that can be also referred as. Each slice is manufactured and deposited and fused together, and there are a number of technologies that exist to enable this fusion. The material can be deposited by dots, lines, or sheets. So, how is rapid prototyping different from additive manufacturing? The difference is in the use and scalability, not in the technology itself. Rapid prototyping used to generate non-structural, non-functional demo pieces or batch of one components, whereas additive manufacturing used as a real scalable manufacturing process to generate fully functional final components in high-tech materials. Additive manufacturing will bring in transformational productivity to the manufacturing industry as a single digital 3D representation of the CAD model can be used by all functions like design, manufacturing, and service organizations. Aside from the potential for lower costs of materials, labor, and other overheads, the primary allure of the additive process is centered on the ability to shorten cycle times and rapidly transition product concepts into physical concepts. 3D printing technology is used in various applications such as jewelry, consumer goods, industrial design, aerospace, construction, automotive, healthcare, manufacturing, developing architectural concepts, and textile, electronics, and more. 3D printing has been used to print organs from patients' own cells. This means that patients may no longer have to wait a long time for donors in the future. More use cases are being discovered every day. 3D printing is not a single technology. Depending on the material and objective of the final application, the 3D object form, fit, and function, there are multiple different additive methods and processes that can be leveraged. Some of the methods used to layering the material used by 3D printers are described in this particular slide. 3D printers deploy different technologies. The basic concept of building up layer by layer is common across all of the different additive technologies that the printers adopt. Stereolithography technology uses a liquid of resin and an ultraviolet laser. For each layer, the laser beam traces a cross section of the part pattern on the surface of the liquid resin. Laser sintering uses high power lasers to fuse small particles of plastic, metal, ceramic, or glass powders into desired shape. Fuse deposition modeling uses heated thermoplastic material and extrude it via a nozzle while the nozzle lays the material down in layers. Laminated object modeling uses layers of adhesive coated paper, plastic, or metal laminates which are successfully glued together. So the selection of this process and the technology depends upon various factors. Some of the factors include material, process speed, volume, and tolerances. Materials are a critical component of the 3D printing process. Some of the most popular materials used in 3D printing include plastics, metals, and ceramics. Materials such as titanium, resin, silver, gold, stainless steel, and bronze are commonly used for 3D printing as well. A 3D modeling software is used to design the 3D model. Today, the modelers have a lot of choices when it comes to designing a new object for 3D printing. Freeware with a lot of design freedom like Blender has the most 3D printing users. A representative list of the software is given on the slide. The 3D printer is a limited type of industrial robot that is capable of carrying out an additive process under computer control. 3D printer vendors are building products for designers, professionals, consumers, and hobbyists. It seems like every week there's a new 3D printer or a 3D modeling app that is getting announced. And of course, everyone has a different opinion about which trend will dominate the 3D printing market. The areas that needs to be tracked are the new 3D printing material inventions and better 3D printers that can print faster, cheaper, and larger, and easier 3D modeling software and new applications that are upcoming for 3D. Finally, a quick summary of the advantages of 3D printing and additive manufacturing. Few questions and looking forward to your posts. Thank you.